Okay, some people ask for a quick review video over inverses. So remember, inverses are when it's like you do it backwards. So input becomes output, output becomes input. So like when I change a tire, what would I do? I would maybe like, raise it up, unscrew all the bolts, take them off, take the tire off, put the spare on, put the bolts back on, and then lower it down, right? So the reverse, you know what I mean? It would be in the reverse order, okay? Because you're undoing things. So like taking the tire off is one process, putting it on is the inverse, okay? So basically you're going to swap. So this is going to become your X. This is going to become your Y. This is going to become your X because the jobs are reversed. We are going backwards. This is going to be your X. This is going to be your Y. This is going to be your X. And this is going to be Y. Because remember, input and output have different jobs. Okay. Now, how do you solve any equation in the whole wide world? Well, you isolate your function and do inverses. So you use inverses to isolate and you keep going back and forth. Inverse of subtracting 8, adding 8. So you want to isolate this chunk first. So as that x plus 8 equals 3 radical y plus 2. All right, how now I'm here. So now I want to isolate just the function part, just this part. To get rid of multiplying 3, again, inverse, divide by 3. All right, how do you get rid of square rooting? Use square. And remember, square rooting and squaring cancels. How do you get rid of adding 2? You subtract 2. And again, that's, on the outside. So f inverse of x for this function up here is x plus 8 over 3 squared. Now, when I graded your quizzes, some of you had like a square root function and then you had more square root. No. Look at this. What does this have in it? It has adding 2. Where did my subtract? Oh, see, I caught my error. There we go. It should have subtracting 2 here, right? Like when I minus the 2 here. So I know I have that. Ooh, this is multiplying by 3. Ooh, dividing by 3. Let's see what else is in here. So the minus 8 is in there as a plus 8, dividing by 3. The subtractions there. Ooh, and I have a square root squaring. Do you see how all the opposite things are in here? I just need to know the right order to do them. So that's where the algebra comes in. All right, let's look at this guy. All right, notice the process is going to be the exact same as what we did here. What did we do? Isolate the function. All right, the chunk first, add 8 to both sides. That's the same thing we did in this problem up here. You get x plus 8 equals what? What is that? 3y plus 2 squared. What do we do next? Again, isolate the function. How do you get rid of multiplying by 3? Divide by 3. This should be very, very similar. I'm going to come over here. And what do I have over here? What's that? Y plus 2 squared. All right, I've isolated my function. How do I get rid of squaring? Okay, square root. All right, here now I have this nice little just y thing. How do I get rid of the plus 2? Minus 2, and again, it's on the outside. So f inverse of x is the square root of x plus 8 divided by 3 minus 2. Okay, now look. Again, it looks very similar to this, right? You're like, oh my gosh, that's kind of similar. Well, why is that? Well, this has multiplying in 3. This better have dividing by 3. This has adding 2. This better have subtracting 2 somewhere. This has squaring. There should be a square root somewhere. This is minus 8, and there should be a plus 8 in there. Oh, sorry. So, you just got to see those. All right. This guy is an easier one, but the process is the same. Isolate your function. Add 8. Add 8. So we get x plus 8 equals what? 3y. Now, so we bring that over. So we isolate, again, what do? We isolate our function by using inverses. Multiplying by 3, the inverse is dividing by 3. That's what f inverse is. Does it look right? Well, let's check. This guy has what? Multiplying and subtracting 8. Guess what? This has adding 8 and dividing by 3. That seems like a really good idea. All right, and then let's look at this one. Okay, isolate the function. So first we have to isolate that chunk. How do you get rid of dividing by 3? Multiplying by 3. All right, now I want to isolate the y. How do I get rid of adding 2? I subtract 2. So f inverse of x is 3x minus 2. Now check your answer. Ooh, dividing by 3, I have multiplying by 3. Adding 2, I have subtracting by 2. And that, those work. Okay. Now, let me take this one as an example just so you understand what's going on. Okay. So the original function was what? K of x equals 2 plus x plus 3. And then the inverse function, we got what? 3x minus 2. So what's happening here? Well, let's make an input-output chart just to see. And you pick friendly numbers. Like, you guys don't have to do fractions and decimals. You can skip those. Pick friendly numbers. When x is 1, I get 3 divided by 3 is 1. All right, let's see. 2 is not great. Let's see what 4 is pretty friendly, right? Let's do 4. I get 6 divided by 3 is 2. Another friendly 7 is pretty friendly, right? For input. Now there's infinite many, and I could do negatives too, right? I'm just picking, friendly numbers. 9 divided by that. Negative, maybe, let's see, a negative 2 is 0, and 0 divided by 3 is 0. So there's infinite many answers if I graph this, right? And by the way, this is a line. If I divide both parts, if you're like, what function is that? There's an invisible 1 there. This is 1/3 x plus 2/3. It is linear. Okay. So notice I have input and output. So what should happen with this guy is I should be able to take the outputs. So outputs 1, 2, 3, and 0. And if I sub them in, these are my, new inputs. My inverse function should take these and go back and give me what I start with. So if I sub in 1, 3 minus 2 is 1. Yay, it works. Sub in 2, 6 minus 2 is 4. See how that gives you the input because it's undoing it. 9 minus 2 is 7, and 0 is a negative 2. That's what happens, all right, when you have an inverse function. Now, when you graph these, they should be symmetrical to, y equals x. So they should have symmetry over that. Now, again, remember, they have to be a one-to-one function. So if it's something like a parabola, sometimes what we do is say, oh, shoot, I'm just going to do half of it because it needs to be a one-to-one function so I can get an inverse. Because remember, one-to-one means pass a vertical line test, pass a horizontal. All right, I'm going to graph this super quick so you guys can just see that on Desmos, and then we'll end this video. Sorry, I have too many mouses here. Okay, here I graphed it. And it might have jimmied a little bit there because I had a few issues, but I went ahead and typed in this, and then I typed in the other function, all right? And then I have y equals x. So this is just to show you symmetry. Those are the two inverses, all right? So they should be, oh boy, I just deleted it, y equals x. They should be symmetrical around this line. So notice on our input-output chart, we had 4, well, that should be 4, 2, if I can get there. There you go, 4, 2, that's my original graph. So then the inverse should input 2 and output 4. So you can see that right over here. Okay, maybe if I can land on it. Okay, maybe, yeah, there you go. I don't know. There we go. All right, so it can go from there to there. And then notice 1, 1 is on both of them, 1 because 1 goes to 1, right? But again, like this point here, this decimal is going to be symmetrical to this one over here, okay? So everything is symmetrical because they're inverses because they undo each other. All right, hopefully that's a good review for you on those, and I'll make a separate video on transformations.